done a couple posts before on material science for cosplayers, and this time I wanted to talk about thermoplastics. Previously I've written about the subjects, but this one works much better with sort of a visual demonstration. So, video! Full motion color! Wah! Thermoplastics come up a lot in cosplaying because Warbla and Wonderflex and Plasticard are all varieties of thermoplastic, as are most of the foams that people use to create armor and fancy accessories for cosplaying. A lot of people talk about it though as if thermoplastics are some fancy magical thing that you can't get anywhere else, when actually most of the things you're likely touching right now are thermoplastics. Your mouse, your keyboard, half of what your shirt is made of is probably a thermoplastic. Thermoplastics is a huge broad category of polymers, and what polymers are large carbon chains. To demonstrate what's going on at the molecular level, I made a frozen plate of noodles. So this frozen stack of noodles does a pretty good job of replicating what polymers look like, or what thermoplastics look like close up. They're very long strands of molecules that are all entangled and stuck to each other, and then cold enough that they get stiff. Depending what kind of plastic you're working with, they'll have different what's called glass-plastic transition temperatures. And that's where it changes from acting like a glass, where you can just shatter a chunk off, to being more flexible and bendable. So if I heat this up a little bit, it'll start to get flexible. If I heat it up more, then those individual noodles or polymer strands will be able to slide past each other a bit and will be much more flexible and stretchy even. And then I can start shaping it into a form. So you can see it's quite malleable now, and if I threw it back in the freezer, it would freeze back up and keep its shape. Now if I heat it way up, then what's going to happen is effectively it's going to melt like plastic, and that is those individual strands will decouple from each other and be able to slide past each other into sort of it's already starting, into a goopy ooze. There it goes, melting, melting, melting. So that's basically what's happening when you heat up a thermoplastic. Those strands are loosening and being able to move around and start to slide past each other. When you completely melt it, it turns into a goo. And then if you freeze it again, depending on the thermoplastic, it might freeze back into a useful form, or it might have lost its consistency entirely. If you heat it up too much, then you're going to start to have chemical reactions happen, meaning that those bonds will break down, those long strands will break and no longer work the way they're supposed to, and you'll have ruined the plastic. So all thermoplastics are those long carbon chain molecules, and the differences between them are sort of the additives to that and the shape those chains make, which adjusts their glass-plastic transition temperature, so whether they'll crack like glass at room temperature or they'll be more malleable, how long that transition phase is between really brittle and completely melting, and also the burning temperature, at which point the chemical bonds are going to break down and change shape based on the interaction with the air. Kitty came to help. Kitty wanted a taste of polymer noodle. Say hello to the internet, kitty cat. Hello, internet kitty cat.